Assalamu alaikum wa rahmatullahi wa barakatuh. Students, we are going to start today another part for triangles. Let us start with, so far we are done with Theorem 6.3. Now let us start Theorem 6.4. Theorem 6.4. This theorem is also called side similarity criterion. So side similarity criterion, or you can say SSS side similarity criterion. This theorem says if three sides, if it is the converse of 6.3 by the way, it says that if three sides of a triangle, three sides of one triangle are proportional, are in the same ratio, then are in the same ratio with the three corresponding sides of the another triangle, then their corresponding angles would be equal. That's what we need to prove. I'll read the statement. If in two triangles, sides of one triangle are proportional to the sides of other triangle, then their corresponding angles are equal and hence the triangles are similar. So what is given? We are given with two triangles. Let us have two triangles. This is one triangle. This is another triangle. Let me name this triangle as ABC, and let us name this triangle as X, Y, and Z. Now, what is given? Triangle ABC and triangle XYZ, in which now it says that corresponding sides are in proportion, in which AB by XY is equal to AC by XZ is equal to BC by YZ. These are the corresponding sides which are in proportion. To prove, what we are going to prove? We are going to prove that their corresponding angles are equal. That means we are going to prove angle A is equal to angle X, angle B is equal to angle Y, and angle C is equal to angle Z, which implies that triangle ABC is similar to triangle XYZ. Because when you will prove that their corresponding angles are equal, so by default the triangles are similar. Construction. Let us have the similar construction which we did in the previous theorem. Take point P on XY and take a point Q on XZ and hence join PQ. Take a point P and Q. I can write take points P Take points P and Q on on xy and xz, xy and xz, such that xp is equal to AB and xq is equal to AC, and hence join PQ, and hence join PQ. Now let us have the proof. Let us first start with this thing that AB is equal to, let us first start with the given. Since AB is equal to AC by, since AB by xy, AB by xy is equal to AC by xz. AB by xy is equal to AC by xz. It's given. Let us take only these two because we require only these two. AB by xy is equal to AC by yz. Why? It's given. Okay. Which implies that. Now replace AB with xp divided by xy is equal to AC with xq divided by xz by construction. By construction. Okay, now look at this. xp by xy is equal to xq by xz. Now by converse basic proportionality theorem, if the sides are in the, if two sides are in the same proportion, that means a line is parallel to the third side. Therefore, I can make one thing: PQ is parallel to YZ. Yes, and reason is CBPT is the converse of basic proportionality theorem. Then, if line is parallel, then I can say this angle is equal to this angle and this angle is equal to this angle. Why? Lines are parallel, so these are corresponding angles. Then I can say angle XPQ is equal to angle Y, and angle XQP is equal to angle Z. Reason? Corresponding angles. You got it? Okay. Then I can say one thing. Make a note, I'll drop it off. So you got one thing that XP, this angle is equal to this angle and this angle is equal to this angle. Now let us consider, let me drop this. So we got corresponding angles equal. Now consider triangle XPQ and triangle XYZ. Got the triangles? XPQ and XYZ. Since, what do you observe in these two triangles? Since angle XPQ is equal to XPQ from triangle XPQ and angle Y from XYZ is equal to angle XYZ, and I can say angle XQP from this triangle XPQ triangle is equal to angle XZY from triangle XYZ. What is the reason from? Just prove. We just proved them here. Just proved. So, in two triangles, two angles are equal. Two angles of one triangle are equal to two angles. Then I can say therefore triangle XPQ is similar to triangle XYZ by angle-angle similarity criterion. Yes. Previously, we learnt about the theorem 6.3. In theorem 6.3, what we learned, that by angle-angle similarity criterion, two triangles are similar. That means if three angles of one triangle are equal to three angles of another triangle, then the triangles are similar. We proved that in theorem 6.3. There is one more point in this theorem. If you just have two angles equal, that means you still say that these triangles are congruent, similar. Why? Because if two angles of one triangle, if you have two triangles for example, and if two angles of one triangle are equal to two angles of another triangle, in that case you can say that by default angle 3 is also equal, third angle is also equal, in order to satisfy the angle sum property of triangle. You got it? Yes. So angle similarity, it is enough to have two angles equal in two triangles. That means by angle similarity criterion, you can say that it is angle similarity criterion, and hence the triangles are similar. Hope you got this. Having understood that, if you just prove that two angles of one triangle are equal to two angles of another triangle, it is sufficient to prove that these two triangles are similar. So what we did the same here. Two angles of one triangle are equal to two angles of another triangle, so the triangles are similar by angle similarity criterion. Yes. Then I can say one thing, that then XP by XY is equal to XQ by XZ is equal to PQ by YZ. Why? Because when triangles are similar, their corresponding sides are in proportion. So I can say CPST, corresponding parts of similar triangle. Yes. Which implies that now XP I can replace with AB by XY is equal to XQ I can replace with AC, because by construction we have these two sides equal. So AC by XZ is equal to PQ by YZ. Got it so far? By construction. So the change is from construction. Now, however, we also know that AB by XY is equal to AC by XZ is equal to BC by YZ. You can refer to given. This is already given case that AB by XY is equal to AC by xz is equal to bc by. Check the given. I rubbed that. You can check the given. So AB by xy is equal to AC by xz is equal to BC by yz. Where I got that? It's given. You got it? Now comparing this and this, let us call this as first and call this as second. On comparing first and second, we obtain, what did we obtain from on comparing first and second? You see, first says this is equal to this is equal to this, second says this is equal to this is equal to this. So this portion is same. AB by xy, AC by xz. So same. This is equal to PQ by yz. This is equal to BC. But that means PQ by yz is equal to BC by yz. We obtain PQ by. We obtain BC by yz is equal to PQ by yz. Now multiplying yz throughout, what do you get? Which implies that you'll get BC is equal to PQ. BC is equal to PQ. Right. Therefore, BC is equal to PQ. Let us call this as equation third. You got it? So BC is equal to PQ is equation third. Make a note. Now consider triangle ABC and triangle XYZ. Sorry, not XYZ, ABC and XPQ. Consider these two triangles, ABC and XPQ. Since now here AB is equal to XP, AB is equal to XP, AC is equal to XQ, both are taken from construction. Number 3, I can say BC is equal to PQ. BC is equal to PQ. Why? From third. Therefore, triangle ABC is congruent to triangle XPQ by side, side, side. This is a congruency axiom. Remember, in congruency, side, side, side means 3 sides are equal to 3 sides of another triangle. In similarity, side, side, side means 3 sides of one triangle are in proportion with the 3 sides of another triangle. Okay. Then what I can say that angle A is equal to angle X, and I can say angle B is equal to angle XPQ, and I can say angle C is equal to angle XQP, and reason for all these is CPCTC. Got it? However, you have already proved that angle XPQ is equal to angle Y. You can refer to the previous page. Angle XPQ is equal to angle Y when we proved that PQ is parallel to YZ. and angle XQP is equal to angle Z. Proved above. You have already proved this. Okay. Then what you got here? XPQY is equal to B and C is equal to. Therefore, I can say angle A. Therefore, angle A is equal to angle X, angle B is equal to angle Y, and angle C is equal to angle Z, which implies that triangle ABC is similar to triangle XYZ by side similarity criterion. This proved your theorem and proved quadratic demonstrandum. Make a note.